I'm going to do another video. This is on percent error, and this is actually one of my favorite topics involved in percentages. It has to deal with a whole bunch of things, and here's really the most important thing to know. You can use the formula. The actual minus the measured divided by the actual. And actually I should say it's the absolute value of the actual minus the measured divided by the actual times 100. And you'll notice I have parentheses in there. And it works like this. Let's say I went outside and I said, boy, it sure is cold. I bet it's like 30 degrees out. And then I found out that it was actually 26 degrees outside. So this was my actual. And by measured, I shouldn't really say measured. I should probably say guess, or, I could say measured, but this would be my guess. All right. So what I'm trying to do is I'm trying to find out how far away is my guess from the actual value. So I'm going to say the absolute value of 26. Oops. The absolute value of 26 minus 30 divided by the actual value, which was 26, times 100. Now I'm going to go back to my calculator, and we're going to take a look at this, and let's see. Now 26 minus 30 divided by 26. Now, once again, you have to be very careful, because if you're going to do this all at once, you need to use parentheses. 26 minus 30 divided by, and what was the actual was 26, so divide by 26, and I get negative 0.153846153. Now remember, I said you have to use the absolute value. Now, it's kind of silly doing this, but I'm going to do it anyway, because I want you to know something. You'll see it comes out to be the positive value of what we initially had, which was right here, all right? When I multiply by 100, that gives us the percent, so it's approximately, we'll say 15.4. So I was off by 15.4%. Now, I'm going to explain why the absolute value was necessary. Let's say I went outside, and instead of guessing that it was 30 degrees, let's say I thought it was 22 degrees. But it was actually 26 degrees. So once again, I'm going to do the absolute value of the difference of 22 minus, nope, that's not true. 26 minus 22 over the 26 times 100. Now, right here, when we first did this, what we ended up getting was 4. Negative 4. Here, when I do it, I'm going to get 26 minus 22, which is a positive 4. So let's take a look. 26 minus 22. And say 26 minus 22 in parentheses divided by 26. And I get the same value as before, and you might be wondering, how is that possible? And I'll explain in one moment. So I do the absolute value of that. It's not going to change anything, times 100. And sure enough, I get the same percent error as the first time I did it. But that doesn't seem to make a whole lot of sense right now. But I will explain it in 1 second. 15.4 degrees, or 15.4%. Now here's the deal. Here's my number line. The actual temperature was 26 degrees. Here's 27, 28, 29, and 30, which was my guess. Going backwards, I had 25, 24, 23, 22, so 25, 24, 23, and then here was my guess again, 22 degrees. If you'll notice, I was equally wrong when I overguessed by 4 degrees as when I underguessed by 4 degrees. However, the actual percent error is how far away I was from the actual amount, which was 26 degrees. So I was off by 15.4%, but here I'm also 15.4% off. It doesn't matter that one's below and one's above, so that's why we don't use positive and negative values. I'm off by 15.4%. It doesn't matter. I can't stress this enough, which is why we use the absolute value, because your values are going to be positive. I am equally as wrong guessing 22 degrees as I was guessing 30 degrees, because I was off by a difference of 4 degrees. So that's it. That's percent error. It's actually really useful. Scientists use this all the time. Normal people should use this all the time. I'm not sure. But in any event, that's it. Hope you enjoyed. Bye-bye.